Hello student, I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start second chapter, Solution. First chapter I finished, Solid State. Now I am going to start second chapter, that is Solutions. What is a solution or what is its need? Why you are studying a solution chapter, that I am telling you with few examples. In a normal life, we rarely come across pure substances. Most of these are mixtures containing two or more pure substances. Their utility or importance in life depends on their composition. For example, the properties of brass. Brass is the mixture of copper and zinc. For example, the properties of brass, which is the mixture of copper and zinc, are quite different from those of German silver. German silver, it is a mixture of copper and zinc. See the differences. If copper and zinc is there, then this is called brass. And if copper and zinc is there, then it is called brass. But if this copper, zinc plus nickel, if these three are mixed, then that is called German silver. Its appearance is like silver. Okay. Then here you can see copper and zinc, it is called brass. Its property is different from German silver, which is the mixture of copper, zinc. Extra thing is nickel. And again see bronze. Bronze is mixture of copper and tin. Then here you can see in all this brass, German silver and bronze, copper is common. Other things are varying. Then see the importance of presence of other things. Okay. 1 part per million ppm is called parts per million. 1 part per million of fluoride ions in water prevents tooth decay. 1 part per million, that is shortcut, it is called ppm. 1 part per million of fluoride ions in water prevents tooth decay, while 1.5 ppm causes tooth to becomes mottled and mottled, mottled, and high concentration of fluoride ions can be poisonous. Then see the importance of, you can say, this thing, concentration. 1 ppm means 1 part per million of fluoride ions in water prevents tooth decay. It is helpful for the tooth. And if it is 1.5 ppm, then now it will affect the bad effect of tooth. And sometimes tooth will be colorful. Fluorosis, one disease name is there, fluorosis, that is due to the fluorine. If it is in excess, then fluorosis, fluorosis, fluorosis disease due to the fluoride ion. And if it is in high concentration, and high concentration of fluoride ions can be poisonous. Then see the value of quantity. If 1 ppm, then helpful for the tooth. It prevents tooth decay. If it is 1.5, then only from that it is harming the tooth. It may become colorful also. And if it is in more quantity, then it may behave as a poisonous. Then see the difference of quantity, it is bringing different property. Then again one more things I want to tell you. Actually all this example what I told, that is asked in examination also. Okay, hence you remember all these things. Now one more thing I want to tell you, just as for example, that sodium fluoride NaF is used in rat poisons. It is used as rat poisons. In killing the rat, sodium fluoride is used. Means this is the poison for rat. Even it can harm the man also. Okay. Then this I have given many examples. In that you have seen that two things are present. In all the things, two things are present. One is liquid for solvent, you can tell. Two things are there, or more than two things are there. Then this mixture is actually, in a broad sense, it is called solvent plus solution. Solvent plus solute is called solution, and in a broad sense, mixture of two or more things. That is called, this mixture is called solution. Correct? Then simple formula you can tell for the solution. The solution is equal to solvent plus solute. Okay. Solute plus solvent is equal to solution. Then in general, solvent is a water. Solvent is a liquid. Generally water is considered as a solvent. It is a universal solvent. And in this water, if you will add any other things like salt, any salt, maybe NaCl, maybe KCl, maybe ZnSO4, maybe ferrous sulfate, any salt if you will add in water, and if you will dissolve it, then again it is a mixture of two things. You can mix two things, NaCl and KCl also you can mix. Three things also you can mix. Then this is actually mixture. Now it is called mixture of three. So three things you have added in water, total 4. But generally we require only one things should be dissolved in water for proper solution. Okay. But solution is the mixture in broad sense, maybe mixture of 1, 2 or 3. Correct? Then here this quantity, whose quantity is more, you suppose you are mixing two things. It is not always necessary that one will be water and other will be solid. Not necessary. Maybe both may be solid. Two things are there, both may be solid, both may be gas, both may be liquid. Correct? It is not this compulsory that that one should be liquid and other should be solid. No, not necessary. Not other things also may be there. Solid, both may be solid. That is called solid solution. Solid I will give some examples, but now understand. Solid plus solid, that is also called solid mixture. Gas may be also there. Two gas can mix. This is also mixture, then it's called gaseous mixture. Like that way, two liquids also can mix. Both will be liquid. Then liquid mixtures. Correct? Then both may be liquid, both may be solid, both may be gas. Or one may be liquid, other may be solid. Just like water, in water you have added NaCl, sodium chloride. Then it is the solution of sodium chloride. Here only I want to tell you whose quantity is more. Out of two, whose quantity is more, that is called solvent, and whose quantity is less, that is called solute. Understood the difference of both? Solute, whose quantity is less, in the mixture, whose quantity is less, that is called solute, S-O-L-U-T-E, solute, and whose quantity is more is called solvent. Then solute plus solvent is equal to solution. Then here I give an example. As for example, NaCl you have added in water. Water is more, NaCl is less. Then it is called sodium chloride solution. Okay, and if you will mix two liquid, as for example, in water you have added ethanol, then again it is a solution. Ethanol is less, water is more. Correct? Then ethanol is a solid, water is a solvent. But in reverse case, if ethanol is more, organic solvent, ethanol is organic ethanol, methanol, chloroform, all are even the benzene, chloroform, I already told you, these are used as a solvent. Ethyl, methyl alcohol, all are solvent. Then here, suppose ethanol is more quantity and water you have added less. Ethanol is in more quantity. Then now ethanol is a solvent and water is solute. But if water is more and ethanol is less, then ethanol is solute and water is solvent. Then like that way, I have given general example. Gas also can be dissolved in water. Gas also can dissolve in any particular liquid, generally water. Then that is also a solution. But suppose gas is less, as for example in water, oxygen gas will be dissolved, but its quantity will be less. That is called dissolved oxygen. In water, dissolved oxygen is required. Already I have discussed previous classes. Then this is also a mixture, oxygen gas plus water or other gas. Carbon dioxide gas also can dissolve in water. Correct? Sulfur dioxide also can dissolve in water. Then this is also a mixture. Then cross, what I am telling, cross means liquid plus solid. Liquid plus solid is also gas. Liquid plus solid is also mixture, means solution. Liquid, gas, correct? And solid, all are the example of, you can say, these things, solution. Already I given example, solid solution, already I told you brass, copper and zinc. This is example of solid mixture, solid solution. Solid solution example is what I given 2-3 examples: brass, copper plus Zn, zinc. Other example I told you, German silver, that is the copper plus Zn plus nickel. Three things. And other also example I told you that bronze, copper and tin, all are the examples of solid solution. Correct? Then I have given some examples, and now you understood in real life only pure things you will get less, always you will get in the mixture form, means solution form. And also I told you that quantity matters. Suppose you have taken water, in that you have put a very small quantity of NaCl, then very small quantity, then you will feel it is very less salty, very less salty. You can add little more also, then it will be a little more salty now. And if you will add more quantity of salt, then now you can't drink that water, salty water, more salty water, just like sea water. In sea, that around 36 gram salts are present, different type of salts are present in sea water. That's why you can't drink that sea water. Sea water is just like you can tell solution only, but in that water many things are mixed. Many things, many salts are, all soluble things are mixed in sea water. Correct? That's why water analysis is done, that what things are present in sea water. Analysis is done, chemical analysis, even biological analysis is also done, because in that many different type of salts are present. Even in our drinking water, many salts will be present, or it is necessary also. These salts are nutrient. We require that salts, but only difference that we require in less quantity, not in more quantity. If it is found in more quantity, then we want to filter it. That's why in your house you are using filter. Okay, that will filter extra, means quantity, they will reduce the quantity. But we can't remove all the salt, otherwise it will affect to our health. Distilled water, nothing will be there, no salt, nothing will be there. Pure H2O will be there, pure water will be there, H2O, pure liquid water. Then that is not good for our health, because their nutrient is not there. Then we need nutrients, minerals, what we are telling, sodium, potassium, calcium, magnesium, iron. Correct? We require all the things, but their quantity should be in a limited quantity. Then that is actually this tap water, you can tell this is also a solution. That's why in a lab, when you are making any solution, that time you require only distilled water, because you want to make some solution. Then in that water nothing should be there, only H2O should be there, and then you can make NaCl solution. Suppose you want to make three type of solution, NaCl solution, KCl solution, sugar solution. Suppose you want to make iron solution or FeSO4 solution, then separate in distilled water you will take, in that calculated amount of all salt you will add. Then if after dissolving, separate water plus NaCl in one beaker, other beaker KCl plus water, third beaker FeSO4 plus water, like that way different solution you are making. Then in that solution what you have added, only that should be there, not other things. In water only, suppose NaCl solution, only NaCl should be there, water plus NaCl. If ferrous sulfate solution you have made, The only ferrous sulfate should be there in water, not other things. But if you will make solution in tap water, then that will be not the correct, because already in tap water many things are mixed. Many things are mixed. Then what you will add from the outside, a little NaCl or KCl, that is useless. It will be error, major error. Okay, that will be the incorrect, not the correct solution. Okay, why that is the reason in a lab, in chemistry lab, always you require distilled water or demineralized water, means mineral should not be present. Otherwise, what solution you will make? Already that things are there. In salt analysis, suppose you got some salt. So then you have to find out in this salt what is the name of the salt, what chemicals are present. Suppose 2 salt mixture you got, and you want to know what type of salts are there. Examiner has given salt, what salts they have given. Then you want to test it. Then to do the test, then now you require different reagents. That reagent must be prepared in distilled water, not in tap water. In tap water, if a reagent you will make, then already that things may be present, or many other things. Then how can you tell that what you made the proper this things reagent, only that things are there? So suppose you wanted to make NaCl or KCl, any solution. Already in that water NaCl is present, along with NaCl, KCl, many other things are also present. Hence, reagent is not correct. Hence, in chemistry lab, if you are making any solution, then you require distilled water or demineralized water. Then now I think you have understood the meaning of solution. Solution means solid plus solvent. Then solution may be of different types. I told you solid plus solid, solid plus liquid, solid plus gas, liquid plus solid, liquid plus gas, liquid plus liquid. Correct? Gas plus liquid, gas plus solid, gas plus gas. Correct? These are the combination. But one will be in more quantity. Then which are in more quantity, that is called solvent, and which are in less quantity, that is called solute. Then now actually I told you, when you are mixing very less quantity NaCl, you are mixing in 1 liter water, then it will be very less salty. If you will drink, I will feel very less salt is there. Then you can tell this is a dilute solution. This is called dilute solution. If you will mix little more, then now you will feel now it is little more salty. That is, now you can say that moderate, you can tell, moderate. But if you will add more, then you can't drink the salt. Then you can tell now it is a concentrated solution. Concentrated solution. If solid quantity is more, then it is called concentrated. If it is very, very less, it is called dilute. Then this is actually called qualitative. Just only you are knowing that okay, it is a salty or it is a sweet. If sugar solution is there, then you can tell, oh, this is salty solution, this is the sugar solution. But only quality you can telling, or some things other bitter things you have added in water, then taste will be bitter. Then only quality you are talking about. But how much that things are there, that you are not knowing. Then This is called qualitative. Only qualitative we are knowing better is that is a solution is salty or sweet or bitter in taste. But this is called qualitative. Quality only you are finding out. But other term is there, quantitative. Then quantitative means now you are knowing that how much salt is present in 1 liter. If both you are knowing that how much salt is present in how much solvent, if both quantity you are knowing, quantity of solvent you are knowing, quantity of solute you are knowing, that solution is called actually a standard solution. Okay, because you are knowing what quantity of NaCl is present in what quantity of water. As for example, 10 gram you have added in a 250 ml water. Then per liter how much? Then 10 gram in 250 ml. Then in 1 liter how much will be there? 40 gram per liter. Then this is called actually a standard solution. Correct? Or if quantity more quantity is present, then more quantity of solute is present in water, then that solution is called concentrated solution. Then what is the this concentration? What is the concentration means? You want to know the quantity, how much quantity is present in 1 liter or in any volume. Then finally actually if you are knowing in 100 ml 5 gram is there, then finally you can convert it in that in 100 ml 5 gram is there. Then in 1 liter 1000 ml is equal to 1 liter. Then 10 times more means 50 gram per liter. You can calculate very easily. That is called concentration. Okay. Then if solute quantity is more, then it is called concentrated. If solute quantity is very, very less, then that is called dilute solution. Okay. Then that I have given you basic idea of solutions. Okay, different type of solutions are there, and in solution actually is a big chapter. Colligative properties of solution is also studied in this chapter, because different type of solutions are there. Then what are their properties, that you will study. Okay, then this colligative properties that depends upon the number of particles. Okay, not on the these things, which type of particle is there, that is not required. Only number, how many numbers are present in 1 liter. Okay, then colligative properties are studied in this chapter, and here you will study that is how solution is prepared, and properties of the solution, like vapor pressure you will study here. Here also we will study colligative properties, already told you, and different types of solution you will study, and various alternatives in which concentration of solids can be expressed, that also you will study. Because concentration, you can, in how many ways you can tell the concentration. Okay, concentration simple meaning you understand that how much quantity, how much solute is present in how much solvent. This is your only these things motive to know the concentration. Then concentration you can tell in different ways. Just like money you can tell in many ways. In India you are telling rupees. In America you are telling dollar. Other countries pound. Correct? But rupees only can convert in pound and in convert in dollar. Then like that way, here you will know the concentration in different terms. Okay. Then now I will go to details. What is actually solution? What is the solution that question is asked? Then solution are homogeneous mixture of two or more than two components. Here components means water is one component, NaCl is other component. Then two component. NaCl means salt, one component, water, other component. That's why it is called binary. Bi means two. If two components are mixed, that is called binary solution. If three are there, then try. Okay. Then like that way, four also may be there. Generally in industries, as for example in paints or industrial solvent, they require sometimes more solute they require in the solvent. In the solvent they will mix. There it is used more. Maybe binary or maybe other tri, tetra, other things also may be there. Then homogeneous meaning, that is what is the meaning of homogeneous? Then homogeneous means if in the solution it is mixed properly, everywhere concentration is a same. Suppose you have made 500 ml solution you have made. Okay, suppose NaCl solution 500 ml. You have dissolved it. 5 minutes you have mixed it. Now you have seen that no particle is settling down. All are dissolved. Then now this solution is called homogeneous because you can't see solid particles. It is mixed properly. If it is solid is settled down, then you can't tell homogeneous. Homogeneous means everywhere concentration should be same. Every drop, suppose from this 500 ml solution, you have taken 20 ml you have taken. Then this 20 ml, suppose you have tested it, because it's a salt solution, you can test it. In lab you can't test strictly. In lab you should not, any solution you should not touch with hand. You should not touch with the hand. Gloves is required. Gloves. And also if you are using the gas or vaporizing anything material, then you should wear the glass also. You should also wear the apron, white this long shirt will come white. What doctors are wearing, that type of, that is called apron. This is actually made for you people only. First it is made for the chemist or chemistry student, then doctors and other things. First it is made only for scientists, chemical scientists. Doctors are just simply to show or make difference from the patients. They will put one stethoscope and this thing, the dress, the apron they will wear. But this is mainly made for chemists, scientists, those who are doing work in lab, any staff who are working in lab. Even a student, when you are going to the lab, if you will go to the lab, then there in lab, before entering the lab, they will ask you that a teacher will ask you just to wear the apron, gloves, and they will allow you so many instructions he will give you, and you should not touch any chemicals by hand. You should not, you can say, any by hand and by gloves is must. And never you to touch, keep anything on the tongue, never. Okay, many things are there that you will come to know when you will go to the lab. Then apron, another thing, full apron required, not your dress, ordinary dress. It will save you from the different type of chemicals. In lab, never you make any joke, because if chemical will make joke, then you will be in trouble. Hence, you should take full precaution when you are inside the lab. Full apron, that hand, any acids and other any acids and other chemicals should not come in contact with your any part of the body. That's why full, it is a full hand. This apron one should wear, gloves, and it should be long so that it can save your this also leg. Like already you will be wearing this your pant shirts, but despite that it should be long. Then it will save your cloth also. Anyhow, that I told you that solution, homogeneous solution means, but here for example I am telling you because NaCl solution, if you will touch, you have taken from 500 ml solution, you have taken just one drop, or you taken in a separate beaker, you have taken 20 ml, a small beaker, and you have tested. Then now you felt some tasty. Again another beaker again you take some 20 ml from that solution only. Then now you will find again taste is the same. Taste is a salty, same salty. It means concentration is homogeneous. Means same type of concentration is everywhere. It mixed properly. It will look like a transparent. Okay. Then solutions are homogeneous mixtures of two or more than two components. By homogeneous mixture, we mean that its compositions and properties are uniform throughout the mixture. Throughout the mixture, composition and properties are uniform. Okay. Generally, the component that is present in the largest quantity is known as solvent. Solvent determines the physical state in which solution exists. One or more these components present in the solution other than solvent are called solutes. If in a solvent two or more you can say substance is present, then that substance is called solutes, or that components other than solvent. Suppose two component is present, FeSO4 is also present and NaCl is also present, then these two are called solutes. Then now meaning of binary solution already I have told you. Now I am giving some specific examples of different type of solution. Okay. Then here binary meaning already you know that two component, and here each component may be solute, may be liquid, or may be gaseous. Keep in mind. Okay. Here each component may be solid, may be liquid, or may be gaseous substance or gaseous state. Now some example I am telling you. Now you are understanding all the things, but I will give some particular example. Gaseous solution. To whom you will tell gaseous solution? Then gaseous solution means solvent will be gas. Solvent will be gas and other solid or liquid will be in a less quantity. Correct? Generally, gaseous solution means solvent is gas, that is in more quantity, and other component are in less quantity. Then here, suppose one I told you gas plus gas. Then example, that is a mixture of oxygen and nitrogen gas. Mixture of nitrogen and oxygen gas is the example of gaseous mixture. Okay. Now, suppose in gas liquid is present. In gas liquid is present. As for example, chloroform is liquid. Chloroform mixed with nitrogen gas. Okay. Then this is the example of liquid plus gas. This is also called a gaseous solution because gas is in more quantity, liquid is in less quantity. And third, in gas, if solid is present, as for example, camphor in a nitrogen gas. Camphor is solid and nitrogen is gas. Then camphor in nitrogen gas, that is also called gaseous solution. Gaseous solution. If gas is more and other things are less, then that is called gaseous solution. Then in these three, you have seen example what I told, that gas was common. In gas, when gas is mixed, that is called gaseous, fully gaseous. And if in gas, second, in gas liquid is present, then other solution. And in gas, if solid is present, then other solution. Now, this I told about the gaseous solution. I told three combination I have told you. Now, liquid solutions. How will you tell liquid solution? Then liquid plus liquid. First, liquid plus liquid. Example, ethanol dissolved in water. Ethanol plus water. That is the liquid plus liquid. This is called liquid solution. Second, in liquid, here also liquid is common. 3, liquid is more quantity. Then now liquid and gas. Suppose in liquid gas is present. Then that is again called liquid solution because liquid is in more quantity. In that some gas is present. Example, oxygen dissolved in water. And third, in liquid, solid is mixed. In more liquid, solid is present. Then solid plus liquid, this is the common. This is the common example of solution. Then example, glucose dissolved in water. Sugar dissolved in water. Sugar means sucrose. C12H22O11. Glucose is glucose is C6H12. Okay, C6H12O11, that is the glucose. And sucrose C12H2211. Glucose is C6H12O6. C6H12O6, that is the glucose. And sucrose is C12H22O11. Okay, it is bigger molecules. Then suppose glucose is mixed in water, then glucose solution. If sucrose is mixed in water, then sucrose, sugar solution, common sugar, which you are using daily. Then like that way, this is called liquid solution. And now you can say solid solution. Then solid solution means first you consider solid plus solid. Already I told you, copper dissolved in gold. Usually when you are making the gold ornament, these things, then that time they will mix around 7% copper to make it hard, because gold is soft, you can't give any shape. very soft. Hence, to make it harder, 7% around 7% copper is allowed to mix. What goldsmith will make, they will misuse it, these things. Even they can mix up to 35 gram, 35 gram, or 35%, 40%, even up to 55% they are mixing to cheat the village people. 30, 35, 40, 45. That's why when you will purchase ornaments, then that time they will take you more money. But if you will go to return to the other shop, goldsmith shop, then they will, no. Suppose it was of 1 lakh rupees you have purchased today, and if you will go after, as you can say, 2 months, due to some circumstances, no, you want to return it, to sell it, then you will go to the any other shop, then they will tell, no, I will give you only 30,000 rupees. They will check it, how much hardness is there. Accordingly, they will return, because that is only copper. And copper is cheaper, and gold is, that it is very costlier. Then they will give only gold cost. Gold is only 30%, 40%. And when say they will mix more copper, then copper cost they will not give, only gold cost they will give. Correct? Hence one should be careful while purchasing the gold. Only one should purchase from the reputed shop, and they should not go after 6 months, 1 year, they will change the place. They are cheating the people. Hence you should purchase from authentic shop with receipt. Nowadays that some mark they are giving on that. Anyhow, I have told you example of solid sol, and solid sol, that is the solution shortcut, it is sol only, it is told. Then solid plus solid, copper and copper dissolved in gold, that is example of can say solid. Here every time solid will be more, other component will be less. And solid plus solid example, copper dissolved in gold. Already other examples I told you. And if liquid is present in solid, then what is example? Is a rare example, less example. But I am telling you liquid present in solid. Then amalgam of mercury with sodium, means Na plus Hg, that is called amalgam. Na plus Hg with mercury, other metal may be present, then that is called amalgam. That is the example. And in solid also gas may be present. What is example? Then hydrogen in palladium, PD, hydrogen gas with palladium is solid. Then palladium will absorb some hydrogen gas. Then hydrogen in palladium. Okay, that is the example of solid solution. Now I am going to discuss very, very important you can say terms, that is the expressing concentration of solutions. How will you express concentration of solution? Already in the beginning I have told you about meaning of concentration. Then how will you express? Then there are 7 ways to express concentration. 7 ways, just like a rupee money, you can express 3 example. I have told you in the whole country, many country they are telling something different for their money, correct? But here 7 commons are there. Okay, then what are that? I will tell you. Okay, quickly you will understand. Then first example, you can express the concentration. You just keep in mind, in concentration here binary solution I am telling you, only 2 components are mixed. Okay, Then here first you can express, that is the mass percentage. Mass percentage. First I will tell the name of the 7 in which you can express. Then one by one I will brief you. Then first is mass percentage. That is by W by W, weight by weight. Second is volume percentage, V by V. Both are in volume. First case both are in weight, mass, that's why it is called mass percentage, or also weight percentage. Both are solute and solvent, both are in you have taken in mass, means in terms of gram. And second I told you volume percentage, means both are in volume, liquid. Okay. And third is a mass by volume. Mass by volume means W by V. W by V. V means volume, W means weight. And fourth is a ppm, parts per million. Parts per million. And fifth is a mole fraction. Fifth is mole fraction. It is represented by a small, just like a small x. And sixth is a molarity, capital M. It is represented by capital M, molarity. And seventh is expressed in molality, Lity, molality, a small m. Okay. Then this is concentration is expressed. Same solution concentration you can tell in this 7 ways. Just like rupees, you can tell in dollar also, you can tell in pound also, and in other currency also. Okay. Then just I will brief you quickly, you will understand. Then first I will tell you mass percentage. You know that solute is dissolved in solvent. Correct? Then here mass of the component in the solution, as for example NaCl. Then mass of the composition in the solution divided by total mass of the solution. Means you take the weight of total solution. Suppose it is 500 gram. And in that suppose 20 gram NaCl is present. Then in that way mass percentage of component is equal to mass of the component in the solution divided by total mass of the solution into 100, because in percentage you are telling. Means in 500 gram 20 gram is present, in 1 gram how much, then in 100 gram how much percentage. Then mass percentage, it is very easy, all are easy only. Then mass of the component in the solution divided by total mass of the solution and upside into 100. Okay. Example I am telling you that if anybody will tell that 10% glucose solution, 10% glucose solution is there, it means 10 gram glucose is present in 90 gram, 10 gram glucose plus 90 gram water, means total became 100 gram. 100 gram means 100 gram contains 10 gram of glucose. Okay. Then it is not necessary always 10 gram and 100 gram will be there. 2 gram may be present in 30 gram. Then you can convert in 100 gram. 30 gram solution contains suppose 2 gram glucose. Correct? Then in 100 gram how much? Like that way you can consider. Then 10% glucose solution in water by mass means that 10 gram of glucose is dissolved in 90 gram of water, resulting in a 100 gram solution. Okay. Concentration described by mass percentage of is commonly used in industrial you can say chemical application. There it is used. For example, this bleaching solution, commercial bleaching solution contains 3.62 mass percentage of 3.62. Okay, then mass percentage of sodium hypochlorite in water, 3.62 means 3.62 gram of hypochlorite is present in water. Total will be 100 gram. In that 100 gram, 3.62 gram is hypochlorite in water. Okay. This I told about the mass percentage. Same way, volume percentage we can know. V by V. Both are volume means liquid sense. Then volume percentage of component is equal to volume of the component divided by total volume of the solution into 100. Correct? Same way, just like weight percentage here, volume of the component divided by total volume of the solution and into 100. Okay, both are liquid. It is important here because volume generally here we are taking as a liquid. Now example, if you tell 10% ethanol solution in water, 10% ethanol solution in water means 10 ml of ethanol is dissolved in water such that the total volume of the solution is 100 ml. Means 100 minus 10, 90 ml water and 10 ml ethanol. Then total is 100. Down is 100, up is the 10. Correct? And you will multiply by 100 like that way. 100% only. 10 divided by 100 and upside you multiplied by 100. Or suppose 2 divided by 50. 2 ml is present in 50 ml. Then in percentage 2 by 50 upside 100. Okay. Then this I have told you about these things, volume percentage. Okay, volume percentage. Then example I am telling you that you should know 35% volume by volume solution of ethylene glycol. It is called this 35% V by V, volume by volume solution of ethylene glycol. This is called antifreeze. It is used in these things, car as a cooling. Just in engine, car engine, it is used for cooling purpose. Okay, ethylene glycol is used as antifreeze, means it will not allow to freeze. Okay, it is used in cars for cooling the engine. At this concentration, means 35%, weight by this ethylene glycol 35 ml and total volume is 100, means 35 plus 65, and total is 100. Then this is called antifreeze. Then at this concentration, means the antifreeze lower. Actually, what will happen at this concentration? Antifreeze lowers the freezing point of water. Water freezes at 0 degree centigrade, but now it will freeze at minus 17.6 degrees centigrade. Minus 17.6 degrees centigrade, or in Kelvin 255.4 Kelvin. This question is asked, what is ethylene glycol, what is the antifreeze, and this what is up to lower, how much it will lower the freezing point. Then freezing point is minus 17.6 17-17.6. Then it is the mass of solute dissolved in 100 ml of the solution. Okay, it is a mass by volume, W by V. W by V, mass by volume. Hence it is called, here it is the mass of solute dissolved in 100 ml of the solution. Correct? One is a solute, that is ethylene glycol, that is a liquid, but its mass is, you have taken 35 gram in 100 ml water. Okay. This I have told about the these things. In medicine also, it is not. I am talking about this. I was talking about the volume percentage, V by V. Then antifreeze example I have given for the volume by volume. Antifreeze, because both are liquid. Ethylene glycol is liquid, water is liquid. Okay. Then now I am telling you about these things. Mass by volume. Third is the mass by volume, means W by V. W by V. Then here what will happen, that here this generally it is used in medicine or in pharmacy. This mass by volume means solute will be in solute mass, solute will be taken in mass, and this solvent will be in this thing cc, volume. Okay. Then this is the unit which is commonly used in medicine and pharmacy, and this is the mass by volume percentage. It is the mass of solute dissolved in 100 ml of the solution. Mass of the solute dissolved in 100 ml. Very simple. This is a common actually. Commonly we are using this, that you will take the weight of any salt. I will dissolve in 100 ml. In 100 ml. Then 100 ml means automatically percentage you are talking about. Okay. Then that is called mass by volume, W by V. Okay, W by V. It is the mass of solute dissolved in 100 ml of solution. Total is 100 ml. Including solid, total volume should be 100 ml. And now fourth, that is the parts per million. Parts per million. Then here by name it is clear, parts per million. Actually sometimes some things in solution will be in very less quantity, very less quantity. Then how will you express this? When a solute is present in trace quantities, very less quantities, it is convenient to express concentration in parts per million, ppm. Okay, and you can write like that: parts per million is equal to number of parts of the component divided by total number of parts of all components of the solution. Upside 10 to the power 6. Million means what? 10 to the power 6 ppm, parts per million. Just like 100 we were multiplying by 100, here 10 to the power 6. That things will be present in very less quantity. Then whatever you have taken the total solution, in that how many parts are present. Then number of parts may be 100 parts, 200, 500. The number of particles, that is the number of parts of the component, divided by the total number of parts of all components of the solution. Suppose solution you have taken, then there suppose it was you have taken 900 parts was there. In total solution, total 900 parts was there. 900. In that 2 parts was one component which you want to know, that is only 2 parts out of 900 parts. Other things are mixed. Then in that what you wanted to know, that is only 2 parts. Then 2 divided by 900 into 10 to the power 6. Correct? Then this is actually fourth one. I told you parts per million. As in the case of percentage, composition in parts per million can also be expressed as mass to mass, volume to volume, and mass to volume. Only this is things that you are parts you are counting parts, but parts have some mass, it can have some volume. Correct? Parts are there. Suppose 20 parts are there, then 20 parts has some mass. Then this is the formula, but you can express it in the mass by mass, V by V, mass by V. It can be expressed as mass to mass, volume to volume, and mass to volume. Example I am telling you, a liter of seawater. It's actually 1 liter of seawater I am talking about. Its mass is 1030 gram. 1030 gram. 1 liter, volume is 1 liter, but mass is more, 1030 gram. This contains, seawater, 1 liter seawater contains 6 into 10 to the power minus 3 gram of dissolved oxygen, which is very, very less. 6 into 10 to the power minus 3 gram of dissolved oxygen. Such a small concentration is also expressed in terms of parts. In terms of, we can express it as 5.8 gram per 10 to the power 6. 5.8 gram per 10 to the power 6 gram. Okay. Or you can tell 5.8 ppm, both are same. 5.8 gram per 10 to the power 6 gram, both are in gram, mass by mass. Also you can tell 5.8 ppm, parts per million, ppm of seawater. Actually, I will tell you that how to calculate ppm. I will tell you numericals when I discuss the numericals. Okay. Then here I told you the concentration of pollutants, the concentration of pollution times pollutants in water or atmosphere is often expressed in terms of microgram per ml, that is equal to ppm, parts per million, both are same. Microgram mu g, microgram per ml. 1 ml is less than that, how much microgram is present. Okay. Also you can tell microgram per ml is also called ppm. Then now 4 I have discussed. Rest 3 I will discuss in the next class, and also I will discuss numericals because it will require more time. Okay. Thank you.